Thanks so much for having me. So I'm James Ward. I'm a developer advocate at Google, and thank you all so much for inviting me to speak and for being here. I love coming to India because everyone is just so excited to learn. So after lunch in America, if I were presenting, everybody would fall asleep, and it seems like that's not going to happen here. So I'm excited about that. Okay, I'm going to be doing a lot of demos. So is this microphone working here? Is that good? No? This one? This one? This one? There we go. Okay. I'm going to be doing a lot of demos. We'll tempt the demo gods again. Okay, so a little bit about me. I've been a Java developer for a long time, and most recently I've started doing functional programming in Scala, a language on the JVM. And so if you ever want to talk about functional programming, that's what I'm most excited about currently. I'm the creator of something called WebJars, which maybe nobody has ever used, but it's a fun little side project that is open source and takes away all my nights and weekends. So that's pretty fun. My blog is jamesward.com, and I'm on Twitter at _JamesWard. Okay, so we're going to try something here where we're going to try to deploy an app from source on the cloud in 3 minutes. And I'm going to start by creating a programming language, because I learned in the last session that's what we do. We create a programming language if we want to do fun things. No, we're not going to create a programming language. What we're going to do is we're going to click a button. So there's a GitHub repo here, and I want to take the thing that's in this GitHub repo and deploy it on the cloud and time me. Let's hope that this takes under 3 minutes. So let's click that button, and then it's going to verify, am I sure I want to deploy this thing on the cloud? I'm going to say, yes, I am definitely sure. And what it's doing now is it's spinning up an instance on Cloud Shell. Cloud Shell is really cool. If you haven't seen it, this is in the Google Cloud Console. And what Cloud Shell does is it just gives you basically SSH to an instance in the cloud that's your instance, so you can do whatever you want with it. So great, so now what it's doing is it's cloning that GitHub repo down to this instance in the cloud, and then it's saying, I need to select a project, so let's just select the only one I have there. And then it's going to do everything needed to get this app that was in that GitHub repo up and running on the cloud. I do need to specify which region I want to deploy this app in, so we'll just specify the central region there. It's also telling me as it goes through what commands it's actually running. So the first command it's running is this Docker build. You saw that one earlier today. And then once the container image is created, then it's pushing that up to the Google Container Registry. And then it's running this deploy command. So one command to now take that container image and get that image up and running on Cloud Run, which we'll talk about in a minute. So it's deploying that service up on the cloud and into the managed environment. It has some settings specified there. But now the app is up and running, and let's actually go try it out and see if it works. Service unavailable. I put that into the code. It always returns out on the first one. Now let's try it again. There we go. Hello world. So I don't know why it says service unavailable the first time, but there we go. Now it's up and running on the cloud. So did I make it in less than 3 minutes to get my app running on the cloud? Is anybody timing me? Is that less than 3 minutes? All right. Okay. It was like less than 2 minutes. Awesome. So that was my app moving from source code to a container and then running on Cloud Run. So there was a lot that just happened in that minute and 45 seconds. And so I'm going to spend the next 40 minutes unpacking everything that just happened and explaining some of the details that actually went on there. Okay. So let's start with first just a little bit of setup. You've seen some presentations already today that describe some of the lower levels of what's happening underneath the covers of all this stuff. So at the base layer with Google Cloud, there's the compute engine, and the compute engine is just your raw server in the cloud. So it allows you to do anything basically that you could do on a Linux machine in the cloud. And so that's infrastructure as a service. And in that world, it's great because we don't have to manage physical servers anymore. So if a physical server breaks, I don't have to deal with that. Somebody else is dealing with drives that fail and power supplies that die and all that kind of stuff. So that's great. There's at least I don't have to think about the actual hardware that is underneath this. But everything on top of that hardware is up to me to deal with. So the operating system, patching the operating system, securing the operating system, all this stuff is up to me in that case. So there's another layer on top of this that we can do to add some more management, and that's the Kubernetes stuff. And so that allows us to deal with a whole bunch of instances and have Kubernetes managing those instances for me. And if I don't want to manage my Kubernetes, then I can use GKE, which will manage that Kubernetes master for me. And so that's now gives me the ability to not have to think about as much stuff to manage, but I still do have to manage some things. I still do have to manage how I actually am going to actually run a container in Kubernetes. I have to think about how I'm going to deal with revisions and load balancers and all this kind of stuff. So that's great. We saw a great presentation on that earlier. So now moving up the stack even more, there's something called Cloud Run on Anthos, and you learned a little bit about that this morning. So this is the ability to take that Cloud Run experience that I just showed you, and I'll be showing you more of in a little bit, and run it on your own GKE or in your own Kubernetes on your own data center. And then there's Cloud Run Fully Managed, where with Cloud Run Fully Managed, now I have traded off some flexibility. So there's some things I can't do in Cloud Run Fully Managed, like if I want to be able to use like a VPC, like that's not something that Cloud Run Fully Managed supports today. So there's some trade-offs, but on the other side, I don't have to manage like anything in this case. Everything is managed for me underneath the cover. So the load balancers, the domain stuff, like there's so many pieces that are managed for me. Okay, so that's the kind of stack of abstractions, and the nice thing is that if you run into a limitation at some place in the stack, you can peel back a layer to drop down to a lower level. And that's a really nice thing about having these things kind of stacked on top of each other. So now let's talk about Cloud Run and what it is. So it's serverless for containers. So those are the two kind of core components, is serverless and containers. So, and it's built on Knative. So Knative you saw at the beginning of today, and that's really the open source building block. So it's nice to have this open source piece underneath Cloud Run so that if we need to make changes or we need to do something that Cloud Run can't do, then we've got Knative underneath it, and we can always drop down to that if we need to. We can get portability of everything through Knative. So that's serverless on Kubernetes. But wait, what is serverless? We talked a little bit about this morning, and someone correctly pointed out that really I think the heart of serverless is that you only pay for what you use. So if you're in the world of dealing with raw instances, then you're getting billed for that instance as long as the instance is running. The instance doesn't care if it's actually doing anything. It doesn't care if there's a web request being processed or some batch job being processed. The instance is going to run no matter what. But with serverless, we only get billed for actual usage of the thing. So what can we use it for? We can use serverless for web applications. We can use it for microservices. We can use it for handling pub/sub events or events from other systems like scheduled jobs, that sort of thing. So lots of different use cases for what we can do in a serverless model. So then all the things that we don't have to deal with when we're in the serverless world. We get a domain name by default, we get load balancing, we get failover. So if our container dies, then Cloud Run or Knative will automatically restart that container for us, so we don't have to think about that. We get HTTPS out of the box for free. We get the ability to do revisions and be able to do traffic splitting across revisions and canary deploys and all sorts of things. We get logging, we get config, and so we're going to go through a lot of these pieces in a little bit. But a lot of stuff just provided out of the box in the world of serverless. Okay, so now we got the serverless piece figured out. So now let's go on to containers. So containers, many of you are probably familiar with containers from the world of Docker, and really you can think of them as just a zip file. It's a way to package up a bunch of stuff and then have it be run on a server. And the nice thing about this is that we can specify the base image that we want to start with. So if you want Ubuntu as your base image, you can specify that. If you want some other more minimal base image, you can specify that. So you get to start with the foundation of the image and build everything up from there. So that means that anything that you can put into this container and run in a container, you can use on Cloud Run. So any programming language that you can put into a container. Then these images, as you saw in the demo earlier, you have to store them somewhere. So you take this, essentially the zip file, this container image, and you have to store it somewhere on the cloud so that the cloud can then access it to run it. And so Google has a service called the Google Container Registry, and that's the default place on Google Cloud where we store those images. You can also use Docker Hub or a number of other places to store those images. Okay, so that's the container bit. But how do we actually create our containers? So we need some way to actually take our source code and turn it into a container. There's lots of different ways that you can do that. I'm going to run through a few of them. So the first one, the kind of traditional way to create your containers is with a Docker file. And a Docker file, if you haven't used one or seen one, it's kind of like a sequence of bash commands that basically say, all right, starting with this image, then do this to it, and then do this to it, and then do this to it. And this allows us to specify these layers that get assembled for these zip files that are essentially just then linked together into our container image. So let's actually go take a look at a Docker file so you can see what one looks like here. I'm going to use Spring Boot and Java for my next example here. Anybody here use Java? Okay, a lot of people. Great, me too. So I've got this Spring Boot project, and we're going to take a look at its Docker file. So we'll walk through what's happening here in this Docker file. I'm saying from, and then some coordinates to where to get a base image from. And so this is, I start with a base image that I'm going to use to build my application from source code. And then I'm going to use a different base image for what it's going to use to actually run it. So I'm using this OpenJDK8 as the builder image. And then I need to copy my source code into this image. So I do that copy. And then I'm going to run Maven package, and then I'm just going to do my typical Spring Boot packaging there. And that's going to turn this source code of my application into something that can then be runnable. And then I'm going to say, all right, now for the actual base image to use when you actually run this thing, let's use the JDK8 JRE instead of the JDK8 that's the actual JDK. We're going to use the JRE one because it's a little bit lighter weight. And then we're going to copy in all the stuff that was compiled from that Maven run step up here. And then we need to tell it how it's going to actually run this application. And I'm just going to use Java-jar. So that's a simple example of how to do it for a Maven Spring Boot application. But those are just the instructions for how to create that container image. Okay, so that's option one is the Docker file. Let's go talk about our other options. So if we're in the JVM ecosystem, there's another option for creating Docker containers called Jib, which provides Maven and Gradle plugins and allows you to create the Docker container from your build tool instead of creating it from Docker. And it will do nice layering of the image as well. Layering is the ability to stack different pieces of what's needed on top of each other. And when you use layering effectively, you can basically say like, all right, my outermost layer is my code that's actually been compiled. Then I'm going to have a layer for the jar files or the dependencies that my application has, because those are going to change less frequently than the code that's being compiled. And then I'm going to have a layer for the JVM, and then I'm going to have a layer for the system. So you want to create these layers in Docker because then the caching actually happens more efficiently when it needs to download the Docker images and assemble them to actually run things. So when you use Jib, it's going to do a really good job out of the box at layering things in the right way. So let me show you how we would use Jib. Back in this same project, I'm going to go to a branch here called Jib. And then you'll see that there's no longer a Docker file there, so I don't need a Docker file anymore. But if we go to my POM that defines my build, you'll see that I have a Maven plugin here for Jib. And then that allows me to, if we go back to the README, if I wanted to create the Docker image here, I would run a Maven command like this one to create the Docker container and store it, in this case, up in GCR. So that's all then built into the build. So pretty straightforward for using Jib. It is built in Java, Jib is, and so it really is just useful for Java build projects, either with Maven or Gradle. So that's an option if you're in that world. Okay, now the next option. So we've gone through Dockerfile, Jib, and then the last option here is build packs. So there's something called the CNCF build packs, which are a standardization effort that Heroku and Pivotal started to create the Docker images for you without you having to do anything. It just is magic. And so if we go look at a project here, so if we go back to our Spring Boot Maven 1, and we go to the build packs branch, you'll see that there's no Docker file, and the POM has nothing special in it about how to create that Docker container. So magically, build packs will turn this application into a Docker container for me, and we'll see that in a minute. Okay, so those are our options for how we create our Docker containers. So now let's actually go deploy an application, and I'm going to use just the build pack support to do that. So I've got another application here called Hello Devfest, and this one is going to use build packs. There's no Jib, there's no Docker file. So let's go run this thing up in Cloud Shell, and let's close down this one so that things don't get confused. Okay, I'm going to say, yep, go ahead and proceed. So now this is going to do, like you saw before, it's going to clone that source code down into my Cloud Shell instance, and then it's going to not run the Docker build, but it's going to run the build pack build on this thing and create the container image, store it in the Google Container Registry, and then tell Cloud Run, create a service from this thing. Okay, so this is going to take a minute. I'm going to, tell it to use my JW demo project, and then I'm going to also have to specify the region to use after we enable the Cloud Run APIs. So we'll use that image there. So now you'll see that the command that it's using is this pack build, and then it's giving it the container image URL to use. It's giving it a path, and then telling it to use the Heroku build packs to actually now build this thing. So the build packs have detected that this thing is a Maven build, and now it's running the Maven build, which is going to download all the dependencies that it needs from Maven Central, and then it's going to run the Maven build, run the Spring Boot command to actually create the jar files that it needs. And it's going to do all that, and it's going to take a few minutes for that all to run. So it's going to keep chugging along there. But while that's chugging along, let's go over and see what this application actually is. So we've got our pom.xml, which is just very similar to the one you saw for build packs, the build pack example, but we're just using Spring Boot, so nothing too exciting in there. And then if we go into our source code, we've got a Java file, and this Java file has our main method that is starting up our Spring application, and then we're setting up a request mapping for /, so when our HTTP request comes in for /, then this method is going to handle that request. So all that this method is doing is it's checking to see, do we have an environment variable named name? And if we don't, then we're going to set name to world, and then we're just going to return hello, comma, the name that was specified. So really, really simple application there that we'll see up here and running in a couple minutes. It's going to take a couple more minutes to get that thing all compiled and turned into that container image so that then it can run on Cloud Run. So we'll continue on and then come back to it in a minute. Okay. So one of the things that Cloud Run manages for you is auto-scaling. This is the ability to scale up to whatever your application processing needs and scale down to 0 when it's not being used. So up and down. Then that's how we get the usage-based pricing, is by scaling up as demand requires and all the way down to 0 as it is no longer needed. The way that this actually works on Cloud Run is that you'll specify the number of requests that you want a given instance to be able to handle concurrently. So you specify the number of concurrent requests to an instance. And so the default is 80. So what that means is that a single instance can handle 80 requests coming in at the same time, overlapping. And as soon as that 81st request comes in, then we're going to need a second instance, and so on and so on. You can set that concurrency limit to whatever you want it to be. But the way that you actually get billed on Cloud Run is you only pay for the total amount of time that an instance is actually being used by requests. So very often you're going to have requests that are coming in that are overlapping. So let's say you have a request come in, and then and that one is going to take, let's say, 5 seconds to complete. But then you have another request come in a second later that only takes 3 seconds to complete. Those two requests are overlapping, and so you're only going to pay for that 5 seconds that outermost request actually took. So you only pay for the time that requests are actually being handled, and that accounts for the concurrency across the instance as well. So that's how and then the auto scaling just works automatically. So the load balancer is going to send requests to new instances and spin up new instances for you as needed. So that's how the auto scaling works. Let's check back in and see if we got our app built yet. Not quite yet. We'll let that go just a little bit longer. So let's talk about cold starts while we're waiting for that. So if you are familiar with the world of serverless, you may have heard the term cold starts. And what a cold start is that when you, let's say that you have 0 instances running, because we need to scale you down to 0, or else we're going to have to charge you for time that you're not actually using things. And so when you're at 0 instances running your application, because there are really servers underneath the serverless, so there are servers under there, and we need to scale those up as soon as there is demand for the application. So as soon as an HTTP request comes into the load balancer, we're like, okay, we need to go from 0 to 1, or this can also happen when you go from 1 to 2, and so on and so forth. So whenever the demand on your application exceeds the supply of started instances, you get what's called a cold start. And a cold start is the time that it takes for that process to actually begin running and be into a state where it can handle the request that has come in. And so this cold start can take anywhere from 100 milliseconds to many minutes, and you don't want your user to be just sitting there waiting for this instance to start up, right? That would be a bad experience for the user. And so how do we deal with these cold starts? There's a couple different options for how we deal with that. One option that is what most people usually try to recommend is that you try to reduce that startup time down as low as you can. So there's different ways to do that. If you're running on the JVM, there's something called GraalVM, which is something that is becoming a really great option for reducing that start time. What GraalVM does is it takes your Java code, which normally runs in the JVM and gets just-in-time compiled. What it does is it actually ahead of time compiles that application into machine code. And so this creates a much more optimized binary that it can run. Unfortunately, Spring Boot does not support GraalVM yet, but other Java frameworks do, like Quarkus and Micronaut, and a number of others. And I know that Spring Boot is working on their GraalVM support as well. So if you're on the JVM, that's one option, is just like use GraalVM to try to really reduce that startup time down. And maybe you'll be able to get it down into the hundreds of milliseconds. If you're not on the JVM, Go starts up really fast usually, especially for small applications. Node can start up pretty quickly for small applications as well. And so that's one of the recommendations you'll receive for dealing with cold starts is just use Go or use Node and keep your applications really small to reduce that startup time. So it's not actually like making the cold start go away, it's just trying to make it less painful, make that cold start take less time. So those are some of the options. Another option that you can do is you can go, if cold starts are really a problem in your case, then you can go with Knative or Cloud Run on Anthos, which allow you to set the minimum number of instances that you want to keep running for your application. So if your concurrency is set at, let's say, 80, and you want to make sure that you can handle 80 requests without any cold starts, then you'll set the minimum instances to 1. If you want to handle, in that case, 800 concurrent requests without any cold starts, then you can set min instances to 10. And you can do that both in Knative and with Cloud Run on GKE or on Anthos. So that's another way to address the cold start issues. In that case, what you're essentially doing is over-provisioning to provide enough demand for your expected supply. And so you can address this as well through over-provisioning. Okay, so that's cold starts. Now let's go check back on our application. All right, our application is now all compiled, turned into a container, and now been deployed on Cloud Run. So let's go check it out here. So you'll see that we got this HTTPS endpoint for the application. You'll see my browser is spinning because Spring Boot is now trying to start, and we should get that app up and running. So this would be a pretty bad cold start if a user was sitting here and happened to be that unlucky request that came in and needed a new instance for it. So there we go. We see our application there. Hello world. Great. So our application is now up and running on Cloud Run. Let's go check out a few things in the console for this application. So this is in the management console, and you'll remember the name of my service was this Hello Devfest. So let's go into that one. And we can see some metrics for my application to see requests that are coming in, request latencies, CPU allocation, all these sorts of things. We can also see revisions. So I've only deployed one revision so far, so we just see that one there. We can see for this revision the settings that it was deployed with, so we can see the container image that was deployed, the amount of memory that's allocated, the concurrency value, request timeout, and some other stuff we'll talk about in a little bit. So great, there's my console there for cloud managing that app on Cloud Run. Okay, let's go now onto the next part of Cloud Run, which is configuration. So with Cloud Run, with really anything now, we need to be able to externalize the configuration from the application. That's a best practice and definitely something you should do no matter what your platform. But on Cloud Run, the way to do this, separate our configuration from our actual running thing, is we use environment variables, and this is what Heroku and many other platforms do. And so this allows us to provide application settings to our application through these environment variables. In some cases, you may use this for secrets to store like usernames and passwords for services that you're connecting to, or database connection strings, that sort of thing. But that may be something that the security people are uncomfortable with. And so you have some other options in that case, like a great project called Burglass, which encrypts the secrets instead. Okay, so that's config and how we do config, and we'll see that in just a second. But we also need to talk about revisions. So revisions, every time you revise your application, create a new version, whether that's a new container image or whether that's changing a setting or changing config, that creates a new revision. And those revisions are gradually rolled out. So what happens is the load balancer, when a new revision is created, the load balancer will start trying to send some traffic to it, and it'll make sure that the thing is working correctly and eventually migrate all of the traffic from the old revision to the new revision. So that all just happens automatically for us. Let's go actually see this happen. So I'm going to go set some configuration in my application. To do that, I'm going to deploy a new revision. Every revision is immutable, so once I create a revision with specific settings in a specific container image, I can't change it. If I need to make a change, then what I'm going to do is deploy a new revision. So we're going to just leave the container image the same. I'm going to leave the memory and concurrency the same. And then I'm going to add an environment variable. And you may remember that there was a name environment variable that was used over in the Java code. So let's go in and put in Chennai there for the name. And then I'm going to hit deploy. And so what this does now is you'll see that I have a second revision in my application, and it currently has 0% of the traffic, but you'll see the load balancer now start to route the traffic over to that new revision. And you saw this earlier with Knative, it was done in the same way. And because it's Knative, essentially underneath here, it's going to work the same way for rolling out the traffic to this new revision. Now it's got 100% of the traffic, and now if we go reload this page, then we see hello Chennai. Okay, so we were able to provide that config and have that new revision deployed. And of course, you can move traffic between revisions and do some of that stuff manually. Not all of the features of that are exposed in the UI. Some of that you have to use the command line for today. If you do need to actually start tweaking some things, remember the YAML from Knative? Well, we exposed that YAML here in the UI as well. So you can see the settings, you can copy and paste this YAML, you can make changes to the YAML, just like you saw with the Knative presentation earlier. Okay, so that's great. Our revision is all deployed, traffic is routed. Now let's go on to what's next. So logging is something that I managed as another part of Cloud Run. And really what it is that it's something called Stackdriver, which is this log system in the cloud for Google Cloud. What that provides us is a centralized logging system. It's external to the application, so no more having to roll log files on the physical systems and aggregate log files so that you can actually search them and that sort of thing. All the logs for your application just go to Stackdriver automatically, and then you can go search those log files, set up alerts, trace through the different parts of the system. The ability to do tracing so that if you have a bunch of Cloud Run apps strung together, or you have Cloud SQL, the ability to trace through all those things and correlate requests through a system is all supported by Stackdriver. And then another piece I want to cover is authentication. So the service that I showed you before is a public service, so it's just out there on the internet, anyone can access it. But we can protect access to our applications through AIM for incoming requests, and then we also can set the account that the container actually runs as well. So let's go take a look at those things, and then we'll wrap up. So over in my revisions, if we go back here, you'll see that, actually, let's look at logs first. So we can pull up logs. This is just a view into Stackdriver, what Stackdriver has. So you can see, here's the logs from Spring Boot that came in. There's the Spring logo and all that kind of stuff. So we can go open this in Stackdriver, filter based on log levels, all that kind of stuff that you would expect for logging. Okay, let's see the service account piece as well. So you'll see that this particular revision is being run with this service account. Service account is just an identity on Google Cloud to run this thing as. So that's the service account that it's using in the container, like that container is executing as that identity. But we can also, as I mentioned, control inbound access to the service as well. So if we go out to this console and then say, show info panel, we can see the permissions for accessing this service. So we have different roles that can access this service, and you can set those up. Right now, my Cloud Run Invoker role is set to all users, meaning anyone can access the service, but we can lock it down to other identities or roles as well. Okay, so that is our login and authentication bits. And so that's all I had for you to give you your quick little intro to Cloud Run. Thank you. That was quite the whirlwind. But if you want to try it out, you can just go to my GitHub and check out the Hello Devfest repo there, and click that Deploy on Cloud Run button, and then you'll be able to get that app up and running on the cloud. Okay, well, I'm out of time, so I'll be around the rest of the day. So if anybody has any questions about Google Cloud or Cloud Run, feel free to come up, and I would love to chat with you. Thank you so much for having me. It was great to be here, and hopefully get to meet many of you. Thanks.